I'm Harita Joshi and I'm a Senior Teaching Fellow with WMG. I predominantly work with the TAR scheme. It's called, and the full form is Technical Accreditation Scheme, which is very closely run in collaboration with JLR and other industry partners. And the idea of this TAR scheme is actually to upskill the industrial workforce in the latest cutting-edge technological developments. But there's also a huge element of academic conceptual knowledge transfer as well. So there is this right balance between academic knowledge transfer and its industrial relevance or industrial technological developments. So I predominantly work in the area of intelligent vehicles, electrical systems, networks and communications. So that's my area. And I lead 3 or 4 TARS modules now. The way these modules are structured, I haven't come across anything like that so far, is every module has an academic lead and then we have a subject matter expert from industry who then provides input on the industrial side. So we have this close match between the academic ideas and the industry needs. And the content is then developed quite closely in collaboration with the industry. And as part of TAR scheme, at times it can be quite challenging to convey complex academic concepts, mathematics, involving mathematics generally. And the audience we have, they're typically JLR engineers, so JLR employees. So they may not have the necessary background, academic background, to actually take in all those concepts, but they are the ones who are going to be applying those concepts in their business, in their day-to-day jobs. So it's quite key that they understand the complex concepts. And my intention most of the time as a module leader is that the fact that they don't have the necessary academic background should not prove to be a hindrance to them taking on those concepts, the understanding. So we have this challenge of how do we convey complex mathematical concepts to engineers who don't have that mathematical background, but they want to understand those concepts because they are relevant to them. I'll give you an example of a workshop that I run. It's connected car communications. So in there, I have to talk about modulation, I have to talk about various effects of mobility of the vehicle on communication environment. That's where I used to struggle to get those things across, those complex concepts across to people, to say why mobility matters. They clearly know it matters, but they couldn't understand why exactly, and I struggled to get that across. And that's where I had to strip down the mathematics of those concepts, and I had to say, okay, well, qualitatively or intuitively, how can I explain that mobility matters, because the signal is going to now split up into multiple parts and then going to affect the reception, and then the car itself is going to have its own electromagnetic model. It's a huge pedagogic challenge to actually be able to convey the concepts without actually having to go into the details of mathematics, and it's been quite successful. I've had really good feedback, and people normally they don't want to go into mathematics that much, but they still understand and grasp the concept why it matters. So that was one recent development that we had, and I actually had to take some advice from colleagues in mathematics actually. And it was an interesting conversation, because for them all it mattered was mathematics, and for me all it mattered was the application of that concept. And we had to have so many discussions and sessions to actually marry those things together. But I think now we've come up with a model that with minimal mathematics we can still get the concept across qualitatively. And so it's I think I've trialed it 3 times now, and all those I think all those occasions the feedback's been really good, so it seems to be working.